this is Haley and Liliana, and today we are going over inertia, force, motion, and friction.
Today we're going to be talking about Newton's first law of inertia, which just tells us that an object in motion stays in motion and an object at rest stays at rest. The thing that stops either of these from happening is force, which is just has it where an object in motion would then no longer be in motion, or an object at rest would no longer be at rest.
So friction is force between two objects, and gravity is force of attraction that pulls two objects together.
So this is basically an example of inertia, as it is not moving at all. And then here, the force breaks the inertia, making it move.
Okay, and now you can see it moving, and it won't stop until we force it to. Okay, and now we're gonna use force to cause the CDs to move again, and the ruler acts as our.
So basically now we're gonna go over friction. So I'm going to drop two different things, a ball of paper and just a sheet. Then we will compare, and then I will explain on how it worked and why it falls different. So as you can tell, the sheet glided through the air, and the force down here, made it slow down and quickly stop. Because there is no sustainable force in this, it was very much easier to fall and drop with the gravitational force.
Okay, this is part 2 of friction. We're going to use a wooden block, and we're just going to slide it across the table. You can see that it stops, and that's because of the friction between the bottom of the block and the table. As they're sliding against each other, that friction causes that force to stop the block. Okay, now we're going to demonstrate gravity. We're going to be using a ping pong ball, and basically gravity just pulls an object towards each other. So in this case, the ball is going to be pulled towards the center of the earth, as that has the strongest gravity. You get the point, it gets pulled down.
So now I'm going to throw this ball so we can see how all of those work. You could see in the previous video, the inertia is me throwing the ball and the ball staying in motion, as well as the friction that slows the ball down as it's midway, and then the gravity pulls the ball down, and then it starts to kind of slow down from the force of the floor.
I will be dropping this ping pong ball, and we will be recording on how long it takes it to go up here from down here. Up here, it is 2 meters long.
Okay, so how these clocks work? This means it's moving. So it's moving like this. This means it's going backwards. It's because I'm breaking out like crazy. This means that it's not moving at all. It just stays in place. And then this means that it's going faster and speeding up.
Okay, so we made a table based off of what we did for our drop. So our x is our distance, so that's how far it traveled. Our t is our time, and then t2 is time squared, so it's just the time multiplied by itself. Now we finished plotting our things on a graph. With our graph, you can see it's somewhat moving forward, but based on what we know, as it goes up, it speeds up. You can tell that it's beginning to slow down because you can see the speed start and then kind of flatten out a bit, but not too much. So it slows down slightly, but it's mostly just moving forward.
Okay, so now we're also going to need to find our gravity, and we're going to use our second plot here, as it is our t squared, and we have our y and our x. So I'm going to pick a plot right here, and as we go over here, we can see it was at 8.6, and we're going to do our y divided by x to get our gravity. And it is
1,333
perfect. So now we're going to take a golf ball and a ping pong ball, and we're going to drop them at the same height, which is 1 meter, and we will see how fast they drop in the distance. So as you can see, even though one bounced more because it is lighter, that they both had dropped at the same speed.
Going back through, we reviewed our data and we are now going to use the equation 9.76 divided by 2 to give us 4.88 for our gravity.
So we just watched the NASA feather bowling ball, and we had seen that with air resistance, the bowling ball fell faster than the feathers, and with not, it didn't. They fell about the exact same time without any air resistance at all.
Okay, now we're going to do the same experiment from earlier, but this time we're going to use an inclined plane and 1 meter. We have our timer here and our ping pong ball here, and we're just going to let go and see how Galileo's theory applies. Okay, so we re-plotted them, and this time our graphs look different than they did the first time, but we also did our first calculations wrong, as we said with the gravity. So afterwards we determined that the thing actually sped up, it did not slow down. So this is how it's actually supposed to be, and it does match after redoing our work.